Have you ever stopped and thought, what connects those ancient plagues, the ones that swept through history, to maybe an infection your dog could pick up today? Seems worlds apart, right? But there's this invisible thread. And today, we're doing a deep dive into that connection. Zoonoses, diseases jumping from animals to us. We'll be focusing particularly on rabies. It's ancient, but still incredibly relevant, and frankly, pretty scary. We sifted through the sources you shared, pulled out the key stuff, and we're ready to get into it.
Exactly. And our mission today really is to unpack how these diseases actually make that jump. Why does it matter so much for all of us, for public health? And crucially, what practical things can we actually do to protect ourselves, especially when we're talking about something like rabies?
Right. So let's start right at the beginning. Zoonoses, what are they exactly? Well, simply put, they're infections, infectious diseases that can naturally pass from vertebrate animals to humans.
Mm-hmm. Vertebrate animals specifically.
And this isn't new, is it? I mean, the sources suggest this goes way back.
Oh, absolutely. This is ancient stuff. We're talking bubonic plague, rabies. Yeah. They knew about these things in antiquity, even mentioned in, historical text, biblical times. It's kind of humbling, actually.
It really is. And it's still so relevant.
Incredibly. Look at a place like India, for example. It's an agricultural country, huge animal population. It becomes a hot spot for these kinds of infections. Things like brucellosis, leptospirosis, and, rabies. They're a constant challenge there.
Okay, so let's unpack how these diseases actually spread. Because it's not always just a direct jump, is it? The classifications in the material are really helpful here. First, you can classify them by the direction of spread. So anthropozoonoses, that's animal to human, like rabies, plague, anthrax, the classics. Almost.
Well, it's the ones we typically think of.
But then, and this surprised me a bit, zooanthropinosis, it's human to animal, like human TB infecting cattle.
Exactly. It can go the other way. And then there's amphixinosis, which can kind of go back and forth between humans and animals, like Trypanosoma cruzi.
Okay, that's one way to look at it. Direction?
Yeah. And another really important way is based on the life cycle of the bug itself, the infectious agent. This helps us understand, where we might be able to break the chain. So you have direct zoonoses. Pretty straightforward. Infected animal to susceptible one. Direct contact, maybe a contaminated object, a fomite, or a vector that just carries it, doesn't develop it. Rabies, a key example, right? Yeah. The bite.
Okay. Direct. Makes sense.
Then cyclozoonoses. These need more than one type of vertebrate host to complete their life cycle. No invertebrates involved, though. Think certain human tapeworms, that kind of thing.
Right, meeting multiple animal steps.
Mm-hmm. Then metazoonoses. Now, these do involve invertebrate vectors, like insects or ticks. And the agent actually multiplies or develops inside that vector. It needs that time. Plague is a good example with the fleas. Or arboviruses carried by mosquitoes.
Okay, so the insect isn't just a taxi, it's part of the process.
Exactly. And finally, saprozoonoses. These have a vertebrate host, but also need a non-animal place to develop, like soil or plants. Certain fungal infections, mycoses, fall into this category.
Wow, okay. So lots of different pathways. And some terms come up with this, right? Like epizootic.
Yeah, epizootic. Think epidemic, but in animals. An outbreak in an animal population, often one that could spill over into humans, like anthrax, flu, or rabies again.
And distinct from enzootic.
Right, and zoonotic is more like endemic. The disease is just constantly present in that animal population at some level. Again, anthrax, rabies, bovine TB can be enzootic in certain areas.
And just quickly, epornithic, that's the bird version, right?
Yeah.
An outbreak in birds.
That's the one. And look, these classifications, they aren't just academic boxes to tick. They're genuinely useful tools. They help us map out these really complex routes these diseases take. And crucially, they show us where we might be able to intervene to break the cycle and protect everyone.
Okay, so let's zoom in now. From the big picture of zoonoses to one specific, and let's face it, pretty terrifying example, rabies, also called hydrophobia. It's an acute viral disease, hits the central nervous system, and this is the key thing. Once you show symptoms, it's almost always fatal.
Almost invariably fatal. That's a stark reality. And this unpredictability you mentioned, not knowing exactly when or if symptoms will appear after an exposure, that's why acting immediately is just so critical. It's not optional.
So understanding the epidemiology is vital. What causes it?
It's a virus called lysovirus type 1. The sources describe it as a bullet-shaped neurotropic RNA virus. Neurotropic meaning it targets the nervous system.
And where do we find it?
Well, it's pretty much worldwide. It's both enzootic and epizootic in many, many places, though some areas are rabies-free, luckily. Often islands or places with natural barriers, Australia, Japan, the UK, even the Lakshadweep Islands in India. But outside of those, yeah, over 150 countries have rabies. And the numbers are staggering. Dog rabies causes something like 99% of human cases, threatens over 3 billion people.
3 billion.
Yeah. And globally, maybe 55,000 deaths a year. India alone accounts for around 20,000 of those. And that might even be an underestimate because of reporting issues.
That's a huge number.
Yeah.
So where does the virus actually live, the reservoir hosts?
Primarily, it's a disease of warm-blooded animals, especially carnivores, dogs, cats, jackals, wolves. In India, as we mentioned, dogs are the main reservoir, the principal one.
But not just dogs.
No, not just dogs. Bats are important too. They can be long-term reservoirs. They can spread it through bites, obviously, but also potentially through aerosols in dense colonies. That makes them a bit unique. And for us humans, we're usually an accidental host, a dead end, really. We don't typically pass it on further.
Okay. And how does it actually get into a person?
Most commonly, a deep bite or scratch from an infected animal. That's the main route. But it can also happen if infectious saliva gets directly onto mucous membranes, like your eyes or mouth. Much rarer routes include inhaling virus-filled aerosols, especially from bats in caves, maybe, or, very rarely, through organ transplants, like a cornea.
And crucially, the sources say eating raw meat from an infected animal is not a risk, right?
That's correct, not a source of human infection. Once the virus gets in, say through a bite, it basically follows the peripheral nerves, traveling up towards the brain.
And the time it takes for symptoms to show up, the incubation period, that varies a lot.
Hugely variable. Commonly, it's maybe 1 to 3 months, but it can be as short as a week or, incredibly, stretch out for years, many years even.
What makes it vary so much?
Several things. Where the bite was closer to the brain means faster. How severe the bite was. How many bites or scratches. How much virus got in. Also, the species of animal that bit you matters. Whether clothing provided any barrier. And importantly, what treatment, if any, was given right away. Generally, though, a shorter incubation period means a worse outlook, a worse prognosis.
And who's most at risk? You mentioned kids.
Yeah, sadly, children often are. They interact closely with animals, might not report a bite, but also specific occupations. Lab workers dealing with the virus, vets, animal handlers, hunters, even field naturalists. Anyone with frequent animal contact, basically. Okay, so given how serious this is, prevention is everything. Let's talk about that. Starting with before any exposure happens, pre-exposure prophylaxis, or PEP.
PPP. Who needs that?
It's recommended for people at higher risk because of where they live or what they do. So those groups we just mentioned. Lab staff, vets, animal handlers, also travelers going to areas where rabies is common.
And how does it work?
It usually involves getting a series of vaccine doses using modern cell culture vaccines, typically over a few weeks, days 0, 7, and then 21 or 28. This builds up your immunity beforehand.
Do you need boosters later on?
Generally, no, not after that primary series, unless you're someone at continuous risk, like maybe a vet working constantly with potentially rabid animals. In those cases, they might check antibody levels sometimes to see if a booster is needed.
Okay, that's pre-exposure. But what about after a potential exposure? Post-exposure prophylaxis, PEP. The sources call this a medical emergency.
Absolutely. It is a medical emergency. The whole goal of PEP is to stop the virus, neutralize it before it gets into the nervous system. That window is critical.
And what does PP involve?
The gold standard is a combination. First, giving rabies immunoglobulin, or ERG, if it's indicated based on the exposure type. We'll get to categories later. Second, a course of the rabies vaccine. And third, absolutely vital, proper local treatment of the wound itself.
Okay, let's focus on that wound treatment first. It seems really important.
It's paramount. Step 1, immediately wash and flush the wound thoroughly. Soap and lots of water, ideally running water, for at least 15 minutes. Don't underestimate this. It can cut the risk of developing rabies by up to 80%.
80%, just from washing.
Huge difference. Then, chemical treatment. Use something that kills the virus alcohol. Iodine solutions, apply it to the wound after washing. And crucially, suturing. Don't stitch up a bite wound straight away. That can trap the virus or cause more trauma. If stitches are needed, wait 24 to 48 hours, use as few as possible, and they should infiltrate the area with RIG first.
Okay, so wash, disinfect, delay stitching.
Antibiotics to prevent bacterial infection, and make sure tetanus protection is up to date. That's standard wound care too. And the good news is, the modern vaccines used for POP, the cell culture and embryonated egg-based ones, are very safe and very effective.
But despite all this, if someone does develop symptoms, what then?
That's the grim part. There is no specific treatment for rabies once clinical signs appear.
None at all.
None. Care becomes entirely supportive, managing symptoms, trying to keep the patient comfortable, managing complications, ensuring nutrition and hydration, and importantly, the patient is potentially infectious then because the virus can be in saliva and other fluids. So healthcare workers need strict barrier nursing, protective gear.
So prevention is absolutely key. Looking bigger picture, how do we prevent rabies spreading in the first place?
It really comes down to two main things: controlling the virus in the animal reservoir and protecting the human population. For controlling the reservoir, especially in places with lots of dog rabies, the most effective strategy and the most cost-effective is mass vaccination of dogs. You need to reach a high percentage, like 80–90%, starting when they're puppies with regular boosters.
Vaccinate the dogs.
Yeah.
That makes sense.
And there's even progress with oral vaccines and baits for wildlife, which has worked well in some areas.
What else helps control the animal side?
Other things include registering and licensing dogs, keeping them restrained in public, sadly, immediate humane destruction of dogs confirmed to be rabid, and quarantining imported animals, usually for 6 months.
And public awareness, I guess.
Hugely important. Educating people about rabies, responsible pet ownership, the importance of vaccination, that's vital. Then protecting people directly involves immunization, both active with the vaccine and passive with rig and just general personal protective measures, being cautious around unfamiliar animals.
Let's talk about that passive immunity part. The rig, Rabies immunoglobulin. When is that used?
RIG gives immediate temporary antibodies. It's recommended for Category 3 exposures, the most severe types. There are two main types: EARS, which is equine, made from horse serum. It's cheaper, but there's a higher risk of allergic reaction, so you need to do a sensitivity test first. The dose is 40 IU per kilogram of body weight. The preferred option, though, is HRIG, human rabies immunoglobulin. Fewer reactions, but more expensive. Dose is 20 IU per kilogram.
And how is it given?
As much of the calculated dose as possible should be infiltrated directly into and around the wound. Any leftover is given as an intramuscular injection, but at a site different from where the vaccine is given, so they don't interfere. Importantly, RIG is generally not needed if someone has already been fully vaccinated against rabies in the past. Their body should mount its own rapid response.
Okay. And you mentioned vaccine schedules earlier. There are different ways to give the vaccine for PP too.
Yes, depending on the vaccine and the situation, doctors might use different schedules. Some involve fewer clinic visits, but might use slightly different injection techniques, like intradermal injections, smaller doses just under the skin at multiple sites to really kickstart the immune response quickly, like an 8-site regimen, some use on day 0.
Right. So lots of options for the medical teams. This brings us to a really practical point. How do doctors, or how should you listening, understand the risk level after a potential exposure? What are these WHO bite categories?
This is crucial. The World Health Organization has guidelines based on the type of contact with a suspect rabid animal. 3 categories. Category 1 is considered slight risk. This is just touching or feeding an animal or licks on intact skin. Also includes minor scratches without any blood oozing, or maybe handling raw meat from a suspect animal. For Category 1, if the history is clear and reliable, usually no PP is needed. Just watch the area.
Okay, Category 1, minimal risk. Intact skin. What about Category 2?
Category 2 is moderate risk. This involves nibbling of uncovered skin, minor scratches or abrasions without bleeding, or licks on broken skin or fresh cuts. Also includes bites that aren't severe, not on high-risk areas like the head or hands. For Category 2, the recommendation is immediate vaccination and thorough local wound treatment.
Just vaccine, no rig for Category 2.
Generally no rig for Category 2. And importantly, for both Category 2 and 3, if the animal involved can be observed, say it's someone's pet dog, and it remains healthy for 10 days, you can often discontinue the vaccine course. Or if the animal is tested and found negative for rabies.
Okay. Then Category 3 must be the highest risk.
Yes. Category 3 is severe risk. This includes any transdermal bite, meaning it breaks the skin or scratches, especially if they draw blood. Any contamination of mucous membranes, like eyes, nose, mouth, with saliva, maybe from a lick. Any contact with bats. It also automatically includes all bites or scratches, even minor ones if they are on the head, neck, face, hands, fingers, or genitals, because these areas are rich in nerve endings. Also, deep, multiple, or lacerated wounds anywhere, and importantly, any bite from a wild animal.
So Category 3 covers a lot of scenarios. And the recommendation?
For Category 3, immediate rig administration plus the full vaccine course. And of course, that critical local wound treatment. Again, treatment might be stopped if the animal is confirmed negative or stays healthy for 10 days.
That 10-day observation period seems key for dogs and cats. But when should you definitely continue the full vaccine course regardless?
You absolutely continue if the animal shows signs of rabies or dies within that 10-day period. If the animal just disappears, can't be traced. If the bite was completely unprovoked from an animal that seemed quiet or docile. Also, if the animal dies and its brain tests positive for rabies. And as a rule of thumb, for all bites from wild carnivorous animals or bats, you complete the course because observing them isn't usually feasible or reliable.
Got it. And just to reiterate, if someone was previously vaccinated.
If they had a full course before and they get exposed again, they generally just need 2 booster doses of the vaccine, usually on day 0 and day 3. No R needed for them. Their immune system is already primed.
Okay. Wow. We've covered a lot. We've gone from zoonoses in general, their history, how they spread, then really drilled down into rabies, how it works, how terrifyingly fatal it can be once symptoms start, but also the really vital steps for prevention both before and, crucially, after a potential exposure. And understanding those WHO exposure categories, category 1, 2, and 3, that seems absolutely critical for you listening, to know what level of risk you might be facing and what needs to happen next.
Absolutely. Knowing that can genuinely save a life. And maybe, as we finish this deep dive, here's something to think about. We know zoonoses are widespread. We know animals play this key role. So how might our world, where we're increasingly living closer to wildlife habitats and also keeping more domestic animals, how might that closeness reshape our public health challenges and strategies in the future? It's a constant interaction, a dynamic we need to keep understanding.